In this last video lecture for Chapter 1, we're going to take a look at the density, which is an important property of most substances which we work with either in the lab. Let's start this again. 3, 2, 1. In this last video lecture for Chapter 1, we're going to take a look at the density, which is an important property of matter. The density is a ratio of mass to volume. The formula written there, density equals mass over volume, sometimes simplified to D equals M over V. Now, densities for liquids and solids tend to be substantially greater than the densities of gases. So when we look at densities of liquids, grams per milliliter is the most common unit, and for solids we use the equivalent unit, grams per cubic centimeters. Why are these equivalent? Because, as you'll recall from the last lecture, 1 milliliter is equal to 1 cubic centimeter. Gases have much lower densities, and that is largely because of their units, grams over liters. It's very important that you realize that, say, a density of a gas might be 3 grams per liter. That is much, much less than, say, water as a liquid, which is 1 gram per milliliter. That unit makes all the difference. 3 grams per liter is a much, much smaller value than 1 gram per milliliter. And if need be, go ahead and do the unit conversions and get them both into the same units, and you'll see that to be the case. Now, as far as densities go, we don't really need to memorize any specific values, although it is a very good thing to know that the density of liquid water is roughly very, very close to 1 gram per cubic centimeter. And you'll notice that this is listed at 20 degrees Celsius. The fact that it specifies at 20 degrees Celsius and at this particular pressure should tell you that the density does vary with temperature most significantly, and also with pressure, but for right now we'll just worry about for temperature. So it's commonly stated that water has a density of 1 when you don't need too many significant digits. You should generally not take that as a given quantity in doing most problems unless you're told that you can make that assumption. So we can see here that the density units for gases are being given as grams per cubic centimeter, and as I had mentioned before, those values are much, much smaller, which is why they're usually written in grams per liter to make the numbers a little bit easier to deal with. You'll notice mercury is a very, very dense liquid compared to many of the other liquids that we deal with. And one question that we want to ask ourselves here is, are these densities exact numbers? Well, when you look at these, do they all have the same number of significant digits? Clearly not. Hydrogen, up towards the top, only has how many significant digits? 2. Good. And then how about magnesium? 1.74, 3 significant digits. So the number of significant digits here varies substantially. And it is possible for most of these materials to get more significant digits than what we're seeing here if we use the information that can be gleaned from more advanced analytical experiments. And in fact, if we look up various sources, we might be able to find these densities to larger numbers of significant digits. So it is not an exact number. These are based on measurements and therefore are not exact. The differences between intensive properties and extensive properties are also very important to understand in chemistry. An intensive property is one which its value does not change depending on the amount of the substance. And when we say amount, we might mean mass, we might mean volume. So what is the density? It is the ratio of mass to volume. So for a given material at the same temperature and the same pressure, its density will always be the same under those conditions. So the density of water, 1 gram per milliliter at approximately room temperature. It doesn't matter if you have 1 drop of it or a swimming pool of it. It's simply going to always be that particular value. So if we wanted to measure the density of something, we could use any amount that's convenient for us. 20 grams, 30 grams, it doesn't matter. In many of the cases, when we're dealing with quantitative variables, we will find that intensive properties are typically ratios. Okay, so you'll usually see 2 units in them. So, for example, grams per milliliter is one. What other things that we've studied in chemistry is an intensive property? Well, grams per, how about grams per mole? Remember grams per mole, that is the molar mass. That is an intensive property. Carbon dioxide, for example, always has a molar mass of 44.01 grams per milliliter. That doesn't vary. Same thing with water. H2O, 18.02 grams per mole. Doesn't vary. Okay. Now, extensive properties do depend on the amount of the substance. So, for example, the mass of a substance is extensive. You can have a different amount, the mass changes. It will take up a different amount of space depending on the amount of it as well. Okay, so let's go ahead here and try a quick problem where we're going to do a conversion here, looking at, first of all, concentrated sulfuric acid having a density of 1.85 gram per milliliter. We want to find the volume of the acid. What volume of it would weigh 74 grams. So go ahead, attempt that problem, and we'll come right back to it. Take a pause. Okay, let's go ahead and take a look at this problem. So we're saying density of concentrated sulfuric acid. We're giving the density in grams per milliliter. We have 74 grams of the acid. Now, just to give you a quick hint, when you're trying to figure out where to start on a problem, it's almost never the case that you're going to want to start a problem with a ratio, grams over milliliters, for example. Not going to be the way that you'll want to go about it. It should always be clear to you that a ratio is used as a conversion factor from one thing to another. So whenever I see something like this, 1.85 grams per milliliter, I might rewrite that as an equivalence factor. 1.85 grams of concentrated sulfuric acid is equivalent to 1 milliliter. Per, what that guy stands for right there, means essentially for every 1. Just like percent, going off on a little bit of a tangent here, means for every 100 parts of the whole. Let me write that whole thing out. For every 100 parts of the whole. All right, so this problem, we just want to go ahead and change mass to volume. Relatively easy problem to do. So we're going to go ahead here and we will start with the amount here, 74 grams. Of acid. Vitally important that the units cancel, so we want grams in the denominator. Grams of acid, so 1.85 grams for every 1 milliliter of acid. So let me go ahead and cancel that out. So we have 74 divided by 1.85. And the calculator for this gives you 40 as an answer. Be very careful because you have to worry about your significant digits. We have 3 significant digits here, 3 significant digits in the denominator. The 1 is considered an exact number. So 40, we need to write that to 3 significant digits. Clearly there's only 1 significant digit there. If we had a decimal, 2 significant digits. So for a 3rd significant digit, we need to go ahead and add that extra 0. All right, and the units left are milliliters of acid. Now this was, to be honest, a relatively easy problem. You'll want to work on a number of problems in the homework until you get more comfortable with dealing with densities, until it becomes very much second nature. In fact, I would like to be very clear and say that many of the problems that we've covered in this video lecture are not terribly difficult. And it's most important that you just use these lectures to get a foundation. The real learning for problems like what we've seen in Chapter 1 comes from doing them. Reading the book, fantastic, you need to do that. But working through the problems, working through a wide selection of problems, working through problems which you have not seen up until that point, but figuring them out, struggling with them, is really the most important thing that you need to master this first chapter, and then in particular chapters 3, chapters 4, and pretty much most of the rest of what you're going to be dealing with throughout the class. A lot of this isn't memorization so much as it is developing good critical thinking skills. So I hope you'll all devote the time and the effort to mastering all the different topics here. So make sure you've done as many problems as you can. I skipped two major topics that are in the chapter, 1.2, the scientific method, and section 1.10, classification of matter. Neither of those are particularly complex topics for you to learn on your own, and so I'm assigning those to you as reading. They might appear in quizzes, exams, homework throughout, so please don't say, oh, you never talked about that. I know that we talked about them in CHEM 120, so please review them on your own. Thank you very much.